Okay, so I've been studying for the electronics exam, and I'd never managed to get the RC circuit equation derivation into my head properly, so I want to show you how I managed to get it going. This is from a video I found, but I've kind of abbreviated down a bit. So we're going to be doing Kirchhoff's voltage law on the RC circuit. So we get V source minus R times I, which is time dependent, minus VC. And we're going to swap IT equal to, the definition for current is charge per time, and VC, we can replace that. We know that Q equals CV, so V equals Q over C. Q over C. So from this, we can replace this with, we'll replace VS with E, just because it's less subscripts, minus R times dq, sorry, I didn't need to, dq by dt minus q over c. So as we see, we've got a first order differential equation, but we can separate the variables so we can actually solve this. And we want to do that by saying E minus q over c equals R times dq by dt. We want to get rid of this c on the denominator here. And we're going to do that by timesing by c throughout. So it becomes EC minus q equals RC dq by dt. So then we want to rearrange this. So I'll do all the steps just so it's easy. So let's bracket this. EC minus Q times dt. Because we're engineers, we don't care that this isn't really a fraction. It's a fraction to us, equals RC dq. Then we want to divide to bring this over here and this over here. So we'll do that, and that gives us dt over RC equals dq by EC minus q. And then we're going to want to, because we've actually separated the variables, R and C are both constant, so this is just t times a number, so we can integrate that. And we can integrate this as well. It's because it's 1 over something, so we know it's going to be a logarithm, so integrate that. And we need our limits for integration. So for this, it's going to be from 0 to t. We don't know how that's going for. And for q, it's going to be from 0 up until q, because we want to know what the charge is on the capacitor plates. So we integrate this, and this just becomes, because this is just 1 over RC, it becomes t over RC. And we do for t, and then minus 0 over RC becomes whatever. So that's just, that side's done. And we say on this side, it's a little bit harder. It becomes log of EC minus Q, and accounting for chain rule, this negative for Q has to come out to the front. But again, let's just dump it over here because it's all the same. And then we have to do this between 0 and Q, which equals log of EC. So we'll do it for equals Q minus Q minus ln EC. And when Q equals 0, it's just EC. And we know that because of how logarithms work, we can write this as ln EC minus Q over EC. So then we've got to this point, we've got negative t equal over RC equals, ln EC minus Q over EC. So let's take, I would call it exponentials of both sides, but other people say that's not correct. And that equals e to negative t over RC equals EC minus Q over EC. And then we want to solve this for Q. So to do that, we'll times by EC. So we get EC e to the negative t over RC equals EC minus Q. And then we can jiggery poke a bit. We want Q to be positive, so we're going to add it to the other side. So we'll move that over here, and then that over to here. So we get Q equals EC minus EC to the E to the minus T over RC. And we can pull out a common factor saying Q equals EC1 minus E to the negative T over RC. And like, how does this help me? Well, we know that Q equals, and we saw it up here, where is it? Q equals CV. So that means V, well, as you can see, if we replace Q with CV, we can just, so we say that equals CV, we can just cancel these C's. So you get V on the capacitor. I'll run out of space because I'm useless. Equals, oh no, it's going so well. Give me a new page. Thank you. So we say V on the capacitor equals E times 1 minus E to the negative T over RC. Because we just resubstituting in this. So we work out Q, and then we can just, at the end, just swap it back for V. And I think it's much easier because you're dealing with dq by dt, which is a separable differential equation. So we get to there. And if you want voltage for the resistor, it's just E minus VC. Maybe work that out because it becomes E minus E1 minus E to the negative T over RC. Every times that out, you get E minus E plus E to the negative T over RC. So they go away. Oh yeah, so that's times by E as well. It's E there. So it's just VR equals E minus T RC. And the current is IC. So the current you just have to remember. So it's the voltage divided by the resistance, because current leads in capacitance and decays times E to the negative T over RC. So there are your three equations for an RC circuit with, I think, a much simpler derivation where you've got a separatable first order differential equation that you can just rejig, and it's all in language you understand, because I know he likes to do it by saying this becomes an integral of 1 over c, and it's just annoying. I don't like it. So I found this much more helpful. So yeah, I hope that helps.